Good afternoon, everyone. I'm Dr. Sridivya, and we'll be learning about environmental impact assessment. So, in the earlier past four classes, we have learned about different impacts on the environment. What are the physico-chemical parameters which are affecting the environment, and what could be the how do we assess it? How do we evaluate the impact? How do we mitigate it? And what will be the role of the stakeholders and the business heads and all these people to make sure that the proposed project will not have any impact or minor impact on the environment. So if we look into that, so there are several processes and methodologies. So we will have a brief uh, look at the EIA process. So there are several EIA process which assess the impact. So first is the screening. Screening and scoping allows the stakeholders or the business leaders to analyze what is the present scenario of the existing land or the present scenario where exactly the project is about to start, and what will be the environmental impact. So to predict what could be the effects of constructing or operation of a particular projects. So then after identifying the impact, so they will be assessing what will be the risk of that impact. So whether it is going to be an air pollution, whether it is going to affect the groundwater recharge, whether it is going to affect the environment, biodiversity, so you name it. So wherever whatever the environmental is, that will be assessed, and based on the environmental risk, there will be a mitigation measures where the alternate strategies can be discussed and implemented accordingly. So the decision makers play the major role in deciding the project going to occur or not. That is mainly done by the public participation and stakeholders involvement, and the funding agencies. These are the decision makers where they will be deciding after reviewing the screening, scoping every step. So basically, if it is a large impact project, then every step will be conducted. Whereas if it is a small scale project, then only they will be deciding after the screening level whether the project is going to take place or not, or maybe even whether the impact assessment reporting is necessary for a particular small scale project or not. The decision making makers will be deciding. So in this decision makers, apart from the stakeholders, business heads, and also the funding agencies, the government people, public participation, apart from all these, again they will be like the involvement of the leaders, particularly if it is if it is related to air monitoring or air pollution kind of a problem, then the experts particular to that main field will be like involved into this project. Then after air, then again water, so water monitoring experts. Then apart from that, biodiversity experts. So the pro people will be involved, also involved in the decision making to further process of the project. And then further, after the decision making, whether if it is finalized, the project is like with a slighter modifications, alterations, and everything, the project will be approved for the further operation and construction phase. Further, it will also be monitored. So pre-project baseline studies will already be done, right? So those studies will be the baseline of the further continuation of the project, where the leaders and everybody, where the project holders will be like monitoring. So pre-existing project, during the project, and post project operational phase. So these are the three stages where the environmental parameters will be assessed and monitored for their possible impacts. So what are the major parameters? So we have already looked into the physico-chemical parameters, mainly the land use, geology, soil, climatic factors, water resources, water quality, air quality, noise level. All these are the physical ones, whereas the biological, particularly pertaining to the terrestrial and aquatic, where the terrestrial, the land should not be disturbed, land as in again groundwater, all these will be involved, whereas aquatic, the marine organisms, or the marine aquatic fishes, the marine habitatory, all these should not be affected. Whereas coming to the socio-economic, the population community should not be disturbed by a particular project. And further the industries as well, industries polluting, like discharging the huge amount of waste, heavy metal toxicity, and toxic wastewater, or the pollutants will be released into the atmosphere. Those kind of things will be involved into this. And agricultural runoff is another major problem, and which consists of major amount of nutrients, which again when leads to the water body, then it will be like eutrophic contamination. And public health, once the hazardous chemicals and everything is released into the atmosphere, the health and well-being of humans will be deteriorated. And apart from that, tourism, transport, and education are also one of the important factors in the socio-economic aspects. And these are the process of EIA. And coming to the methodologies, we have decided for a particular project what kind of methodology should be involved. If it is a large based project, which methodology? If it is a small scale, what methodology to be adopted in order to further minimize the effects, and accordingly the decision had to be taken. So the what is the main purpose and scope of these methodologies is to list the environmental issues, and also to involve the stakeholders, the time, the how much time, the duration of the project, the money is going to take place out used during the project. All this will be the major concepts. And second, whether the EIA is going to be ensuring and meeting the standards and also the regulations of the government guidelines or the international guidelines, national guidelines, and all these. So the methods and techniques, once the project is established for based on its purpose, scope, and meets the standards and regulations, which method is mainly chosen for which type of projects will be done in during this step. All right. Then the next one is the EIA quality and the effectiveness. Mainly ensuring the EIA quality, the stakeholders, and the experts through the EIA project. Like as I told you, the experts, water experts, environmental experts. All these people will be thoroughly involved into the projects, and for this, multiple sources and methodology for will be used for the data collection and analysis are necessary, and further applying these principles and certain in order to get back to the sustainability and precaution documenting and EIA reporting will be further processed. So these are the major methodologies involved. That is mainly to identify, predict, evaluate, and assess the impact of a proposed project plan or a policy or a program. And these methodologies provide a framework for conducting a study of EIA to ensure all the relevant environmental factors are considered. So these are the methodologies. One is the network method, ad hoc method, checklist, matrix, and overlay method. So we have discussed everything in the previous class. I'm just giving an overview of these methodologies. Ad, ad hoc methods are the like heavily directly depending on the expert judgment, all right, only to identify the potential impact. So based immediately, if there is a disaster or if there is any immediate project going to construct at instant, then immediately the experts whoever is present, they will only decide whether it is going to taken place or not. So this is mainly the ad hoc method. So immediately, like based extremely on the expert judgment. All right. And then checklist, if there is a checklist as in we will be listing out all the environmental parameters, what all the project will be affected by, if it is a local community or whatever it is. So mainly this method assess the nature of impacts, whether it is adverse or beneficial, short term, long term, or no effect or significant impact. So all these will be like listed, and among which whether the project is going to be in producing adverse effect or it is beneficial for the environmental and also for the local community, whether it is short term or the long term. So all these will be like in a written in a checklist mode. And matrices are the two dimensional table where the interaction between the project activities and the impacts will be like assessed by this matrix methodology. And network method is to identify the cause of the project and what will be the effect of the cause. All right, it will be visually represented the chain of impacts, including the primary, secondary, and higher order effects. Whereas the overlays is another method where a series of transparent maps, where everything like environmental characteristics, whether land use, vegetation, water resources, or terrestrial, everything will be mapped in this overlay method. And in environmental index using factor analysis, mainly this method uses this statistical analysis to analyze the environmental data, creating the whole environmental index. All right, so as we see here, this is the Delphi method, which is mainly used by the ad hoc method, where mainly only experts will be, that is the judgment will be taken only by the experts to come into a common conclusion. All right, and this is a checklist method where the parameters and their impact, like whether it is a site clearance, what is the thing impacts and everything will be under this checklist method. This matrices method, as we can see, we will be going through which impact is having what kind of which level and all. Overlays by using mainly geographical information system, that is mainly by the statistical analysis and also like um, satellite imagery. So these all with the use of GIS particularly and remote sensing, the information will be gathered and it will be visualized in this way. And this is the network method where mainly like how each impact or a project, like the other impacts and everything, how is each other interrelated. So whether it is disturbing the food chain, whether it is disturbing the flow of the living and all, it will be like interconnected. So based on the project, which method should be adopted is the crucial step. All right, so these are the methodologies which are mainly useful for this. And these are the benefits of EIA, where it is by performing this EIA reporting of a particular project, by which there are several benefits. One is the lower project cost in the long term. It minimizes the cost of the budget. All right, so it minimizes the budget and increase the project acceptance will also be there by analyzing this EIA. Once we analyze the EIA, we will be coming to know about the adverse effects. So once we come to know the adverse effects, we'll try to mitigate it. So what are the mitigation measures? What can be done? All these things will already be reported in a project, such that there will be more chances of acceptance of the project by the stakeholders. All right, next one will be the improved project design. So based on the mitigation measures, based on the severity of the impacts and the adversity of the impacts, the project will be changed accordingly. Will be changed accordingly such that they will be like minimal adverse effects. So the changes will be done in the project, due to which the project will be even more improvised. And in environmentally sensitive decision, that is the decision will be done by the stakeholders, that is whether to be taken or not to be taken. And in the favor of the environment, all right, the decision will be taken. And increased accountability and transparency in for the public people particularly, such that the local community or the public participation, so people will be aware of a particular projects and what could be the severe impacts of the projects. So they, since there is a transparency, people will be aware of that, of the effects and the mitigation measures as well. Through this EIA also, they will be like employment as well. And economically, employment wise, everything will be like improved, so people also will be aware of the project. So they will be considering the employment opportunities and positives, negatives, all these they will be like open up. And reduced environmental damage, of course, like once we know the adverse impacts and the mitigations, they will be reduced to environmental damage. And improved integration of projects into their environmental and social settings, right? So these are the benefits of EIA. So now if we come into like different aspects as we have previously looked into. So we have looked into air, water, soil, biodiversity, environmental conservation, marine, aquatic, human well-being, socio-economic aspects. So these are all the physico-economical parameters and physical parameters and socio-economic parameters. So as we have previously looked into this physical and chemical for the socio-economic and biological ones. So here particularly we will be more discussing about soil and groundwater environments. So first we have to see what are the objectives of this EIA, particularly for the soil and groundwater environments, for which we have to see the potential impacts. So if we actually think what could be the potential impacts of soil, so soil will be degraded as in the composition of the soil will be changed, the structure will be changed, the soil structure, it varies based on the soil type. And also the fertility again based on the nutrients present in the soil, which allows the soil to be fertile and ensure the healthy growth of plants. All right, so it will actually determine how the project might alter this composition of the soil structure and the fertility of the soil. And also pertaining to groundwater, they will assess the risk for the groundwater contamination. So basically what could be the risk for the groundwater contamination, might be the cause of acid rains, or might be because of the leachate infiltration and all these. All right, so they will assess the risk of the groundwater contamination, depletion, and changes in the flow pattern. Okay, so these will be the potential impacts. And how do we evaluate? So determining the magnitude and extent of the potential impacts, as in we will identify like till what extent, what is the magnitude of it, till what, so what is the maximum impact of it. So we will be giving rating. Okay, okay, this project is going to pollute it. So if, for example, if it is agricultural wastewater, all right, so agriculture runoff particularly has huge amount of nutrients. So those excess nutrients, what happens is that during the runoff they ultimately reach the nearby water body. So once they reach the water body, it pollutes it, making it eutrophic. Eutrophication is nothing but huge amount of excess level of nutrients present in the water, which is not a, which is not a positive indicator, but it also affects the environment in an aesthetic way, in a, human well-being, because it is not potable water, it is not used for the consumption, drinking, or any of the domestic purposes also it is not used. So in that way, all right, so we will evaluate the magnitude of it, in which manner the soil is getting impacted, and what could be the maximum effect of it. And also for groundwater, we will be assessing the sensitivity of the affected soil and groundwater resources. And based on the impact and the significance of the impact, we will be developing the mitigation measures. So how to reduce or to minimize the adverse impacts on the soil. So how the project should be deciding, or project should have a mitigation measure in order to minimize the adverse impacts on the soil. And also the monitoring program should also be there in order to track the environmental changes. As and when the mitigation measures are implemented, then the monitoring of the program should also be done in the future purposes as well, in order to keep a track on the environmental changes. So pre-project data will already be present. During the project, the whatever the data is available, those data will be present. And how do you track the environmental changes also, those things are also. So pre-project, during the project, these are all the baseline data. So that data, based on that data, future monitoring of the environmental impacts also will be useful for the comparison and how the project is affecting the environment. All these will be involved, and it is always highly recommended. All right. So what will be the key considerations in environmental impact assessment for the soil environment? Mainly, if you look into the soil assessment, basically it will come about the soil characteristics. Characteristics as in the soil has a texture, right? So whether it is like small, big, or rough, or porous, non-porous, that kind of thing. So we have to analyze the texture of it, and the pH of the soil, organic matter of the content, and the nutrient levels of the soil. So these are the different soil characteristics which should be assessed accordingly. And the potential impacts. So how the project is impacting the soil characteristics, whether to evaluate the risk of soil erosion. So the soil is already degraded by the project. So how to evaluate the risk, so how the soil is getting eroded, and the compaction of the soil, contamination from the pollutants, and the loss of fertility. So these will be the potential impacts. So the soil, so how do we even do the analysis for all of these? By taking or collecting the soil samples. So if there is a project to be performed at a particular place, say XYZ, so from that particular place, pre-project data, baseline data will already be collected by going to the site, collecting the sample, and then coming back for the laboratory analysis for its organic matter, nutrient levels, pH, whatever it is, So all these analysis will be performed in the laboratory by collecting the soil samples. So these soil samples are to be collected from a representative area of a proposed project for the laboratory analysis. Whereas coming to the groundwater assessment, mainly the hydrogeology, that is mainly the study of groundwater flow patterns. So there is some flow pattern, whether it is like to gravimetric or gravitational flow, or if there is any, like, ups and downs, all these, like, there is a particular pattern or there is a particular flow where the water will be conveyed, that water will be transported accordingly from one place to another. So that flow should not be disturbed. So the study of the flow patterns, then aquifer characteristics. Aquifer is the storage of water in the form of in between the sand pores, and between the rocks or such things, where water will be present in that. And the recharge rate as in groundwater recharge, that is groundwater, what do you say, the increase in groundwater level particularly. So if there is more amount of water, there will be more amount of groundwater recharge. So that is what is called recharge rates. All right. So we will be assessing, like, to study the groundwater flow patterns. Then what are the aquifer characteristics? That is how much porous the aquifer or the sand layer or the gravel is. That and all characteristics will be studied, and also the recharge rate, the percent of recharge by during this process and all. And then we will be looking into the water quality. So water quality is mainly by analyzing the physicochemical parameters of it, to identify the existing contaminants. Contaminants, as in we have already discussed, right? Contaminants are nothing but we will be looking into heavy metals, the toxicity of the water, and the nutrients, particularly the nitrogen, phosphorus, and then lead, all these like toxic and heavy metals contaminations, PCB. So are there any microplastics? So all these, anything like these are all come into this emerging contaminants. Either it could be nutraceutical or pharmaceutical, cosmeceutical. So all these also will be like mainly the emerging pollutants will be present in the polluted water. So mainly the groundwater quality will also be analyzed to identify the existing contaminants. And about the potential impacts. So there will be some potential impacts of groundwater contamination which will be assessed. And the contamination could be mainly from the oil spills, the leaks, or the agricultural runoff, and also by the depletion of the excessive pumping. So more amount of groundwater pump is pumped, the more amount of ground is getting deteriorated, and through which there will be some depletion, like there will be a crack or something where the aquifer will be like contaminated by these spills, leaks, or the agricultural runoff. So how do we do that? How do we know all these impacts and quality? So majorly by collecting the samples. So how do we collect? By existing wells or the boreholes for the and will be given to the laboratory analysis. All right. So the groundwater samples will be sampled, collected, and transported to the laboratory for the analysis of these contaminants and all. So what are the major impacts from various projects? So projects which are contaminating the groundwater are the industrial activities which have the major potential for the chemical spills and leaks. Yeah. Then agricultural practices, risk of contamination from fertilizers, pesticides, all these. So major amount of nutrients which will be either infiltrated or goes to the nearby water body, and causes eutrophic. And the mining operations, like presently, like basically potential for the soil erosion, mainly due to the acid mine drainage and groundwater contamination, and construction. These mining operation particularly, there will be large acid mine drainage, and also large amount of heavy metals, lead pollution, and all these also will be produced. So construction is also one of the biggest project where it also has a huge impact on ground as well as the water. So there will be a potential for soil compaction, erosion, and changes to runoff water. So coming to the mitigation. So coming to the mitigation and monitoring of these. So basically, they implementation of erosion control technologies, establish the contaminant systems for the potential pollutants, and also to develop the groundwater monitoring programs and proper waste management, and implementation of the proper drainage systems. And also the main importance of this EIA is to protect the soil and groundwater resources from degradation, and to ensure the sustainable development by minimizing the environmental risk. And it also provides the basics for the decision making, and avoids the costly environmental damage and remediation. So mainly, if you look into this, like what could be the steps involved for this? So we will be looking into the delineation of the study area, where it is the major steps where we will be deciding the boundaries of it, within which the assessment will be conducted. So first, the study area where exactly the project is going to be conducted, the baseline or the boundaries, the spatial boundaries will be done by the with the help of GIS. So these boundaries will be created, and the study area will be continuously monitored or looked into about for their potential impacts. The study area also reflects the possible effects within the particular impact, discipline that is considered majorly. So the study area, if we consider from A place to B place, all right. So what could be the effect of it? If there is a huge rock formation, or if there is a water body nearby, so how it is going to get impacted? So for example, there is a nearby pond in a study area. All right. So that pond, how it is getting affected by a project area? So they cannot the project leaders cannot leave the pond area just like that, right? They will be like closing the pond. So the pond is closed with the help of soil. So on the pond, the project will be constructed. So that is how the pond is going to get disturbed. So this is how the effect will be. And the proposed land use map, okay, all the proposed land use map along with the land use policy, zoning, different projects should be included in the study area. So land use mapping by the use of remote sensing and all these will be conducted in order to looked into the developmental projects in the which should be also included in the study area. And the map should be distinguished between the developed and undeveloped land. So there should be also, like, if it is an undeveloped land, so undeveloped as in there will be no nearby local community or the business where the land has huge price value. And it should also be distinguished between the developed, that is a way if it is like a huge number of people with a good local community with a good business taking place and all that, that is also the developed land where the good life is going on. All right. And mainly the categories include under this process is the residential, commercial and industrial, institutional and parks or recreational activities will be taken place, and non-urban mixed. All right. So these are the several categories which are included for the developed and categorized between the developed and undeveloped, and that is the land use, particularly the land use map will be considered. And the categories to be used will be depending majorly on the project type, the land area characteristics, and the geographic extent of the project potential impacts associated with the proposed projects. So basically these projects will be depending on these three of the impacts. And if we look into the direct land use impact, so directly the land where it is directly affecting, so land as in mainly the landforms. The landforms are nothing but see, if you look into this, so there are different type of landforms, whether it is a hill, it is an island, is it's a different ones. So these mainly, whether landforms are the physical features that hold the recreational, educational, scientific significance, which also includes the natural and geographical formations, and along with the water bodies, landscapes, ecosystems, which are uniquely in a local way or on a larger scale as well. These features often serve as tourist attractions and research sites or educational resources. So these are the different features which will attack these majorly these landforms. Understood? So landforms are nothing but any geographical or the natural formations which mainly serve as the tourist attractions, research and for the educational purposes for the research and all. So mainly the important physical features of these landforms are the mountains and hills. That is mainly used for the recreational importance is that these are used for hiking purposes, rock climbing, skiing, and sightseeing. Whereas when it comes to the educational or scientific interest, it comes under the geological studies, that is rock formation, plate tectonics, climate research, biodiversity conversions and conservations and all these. When coming to the rivers and lakes, mainly the recreational importance is mainly the, as we all know, the boating, fishing, ecotourism, swimming and all these. Coming to the scientific interest, mainly the hydrology studies, water flow pattern, water quality assessments, aquatic biodiversity, and research. So, if it is a sandy beaches, for say, other than mountains, other than rivers, if it is a sandy beaches, the recreational importance is the sunbathing, swimming, beach sports, surfing, and coastal tourism. Yeah, for the scientific interest, it is mainly the coastal erosion, marine biodiversity, climate change impact, that is mainly particularly for the rising sea levels and the coastal protection. And mainly for the examples of this is mainly the Bondi Beach in Australia, which is mainly used for the surfing and ocean conservation research. All right. These are about the landforms. And the lagoons, if we say, the lagoons are the main recreational importance is for the hiking, kayaking, bird watching, ecotourism and all. Scientific research, in terms of scientific research, it is mainly coastal hydrology studies will be taken place, wetland ecosystem habitat for migratory birds and aquatic species. So these are the scientific interest. And main examples for this is the lagoon, which is a Vietnam lagoon in Italy. Mainly it is for the human interaction with coastal environments, whereas Chilka Lagoon in India, which is a biodiversity hotspot for fish and bird species. Alright, these physical features particularly contribute significantly to the global and the local ecosystems, which mainly supports the scientific advancements and also provide the opportunities for the recreations, while also emphasizing the importance for conservation and sustainable management. All right. So mainly, apart from the landforms, the soil profile also has to be looked into. So the soil profile. So what is the soil profile? Soil profile is a vertical arrangement of different soil horizons, reflecting the soil formation process. Mm, what are the different soil formation process here? Mainly the topsoil removal. See here, as we can see, there is a humus is the one which is like very nutritional source of the soil, all right, which mainly enriches the plant growth and also enriches the microenvironment present inside the soil. And topsoil is also like highly nutritious also as well. And subsoil, weathered rock and fragments, and this is the major bedrock what is present. All right, so how these soil horizons are getting disturbed by a particular projects, so we will see into this. All right, so soil profile is the vertical arrangement of the soils, reflecting the formation process as well. All right, the impact mainly the removal of the topsoil. So topsoil is removed during the construction. So yeah, once it is dug out or taken out, and the fertile top layer is often lost, reducing the soil productivity. All right, the compaction is that by using the heavy machinery compacts the soil, reducing the porosity and infiltration. So heavy machinery such as this um, JCB, all these, they will first of all eject the soil from the ground, disturbing the soil horizons, and then they will try to fix it again. After digging the hole, they will again put the amount of soil, and then they try to compact it. That is, they try to press it. By doing so, they will by the porosity. Porosity is nothing but the air gaps between the soil particles or between the rock particles. That is the porosity, and this is the place where exactly the air will get trapped, and that is how the oxygen or air is provided for the micro community or the micro environment organisms, who survive at the in the micro environment. They will be surviving with the help of that kind of porosity where air is produced through it. So air getting trapped in these pores will be getting affected, and infiltration process also. If there is no proper alignment of the soil profile, the infiltration doesn't occur properly. They will be just running off after the wall, after the rainfall. So mixing of horizons. So horizons during particularly during constructions, soil horizons are mixed, disrupting the natural soil structures. So these are the different horizons, right? So during the excavation of the soil for the construction process, all these the layer of the soils will be removed and then again put into it, and compaction of the soil will be done, by which there will be a disturbance created. Subsoil may come up or topsoil may go down, or topsoil is further left of sidewards. And so there is a proper process for the infiltration. There is a proper process for the layering of the soil. So once it is disturbed during the excavation process of the soil, the mixing of horizons occurs, which is not a good sign. And erosion. So mainly because of the deforestation and intensive agriculture, these mainly accelerate the erosion. So deforestation as in cutting down the trees. So once you cut down the trees, again there will be a disturbance in the nature, and the soil also is getting affected by it, and ultimately causing the erosion, and removing the topsoil and exposing the subsoil. All right, so this is how the erosion occurs, and that is how like erosion is one of the major impact while during the excavation process or the deforestation process. And detailed implications are: the loss of topsoil mainly reduces the nutrient availability and the water holding capacity. Yes, these soils, na, generally they have the ability to hold the water for long time. So that is how there is a, I told you about porosity, right? So these pores are mainly the air gaps where once the water is getting infiltrated, that is water is getting absorbed into the soil, these pores will be trapped with water, and that is how the aquifers forms as well. And uh, once there is a topsoil, like majorly that is more nutritional layer of the of the soil horizons, it loses, once there is a mixing of horizons, once there is erosions, compaction, removal of the topsoil, all these they will be like exposing to the subsoil, and also there will be lower level of water holding capacity. All right, so the compact soil also reduces the root growth, mm, and water infiltration as well, leading to runoff and erosion. Once there is no proper holding of water or no proper producing of nutrients to the plant, and all these particularly, mm, yeah, so these are the major causes, and all these particularly causes the detailed problems of the impacts caused by a particular project. And the disrupted soil profiles also alter the soil hydrology and the biogeochemical cycling as well. All right. So if we look into the composition, so initially we have looked into the profile where due to the removal of topsoil, be it the compaction of the soil, be it the exposure of the subsoil, be it because of the erosion process and everything, the nutrients will be like run off, and then nutrient availability nutrient availability will be less, and water holding capacity will be lower rate, and more amount of erosion, and decreasing the quality of the soil and also the quality of the plant growth. So if we look into the soil composition, all right. So if you look into the soil composition is mainly, it is composed of chemical, physical, and biological makeup of a soil. So mainly the contamination of different industrial discharge, agricultural runoff, and waste disposal, which mainly introduce the pollutants, particularly heavy metals, pesticides, hydrocarbons into the soil. So this soil composition is varied or impacted by the contamination which is done by the industrial discharges, agricultural runoff, and other pollutants into the soil. Salinization, that is mainly caused in the irrigation regions, maybe particularly in the arid areas, which can lead to the salt accumulation in the soil. So maybe particularly in the coastal regions as well, where more amount of soil water is present, salt water is present, where the water when it gets in contact with the soil will be getting accumulated, due to which there will be no water holding capacity of the soil. So if we see the sand in the beaches particularly, because of the presence of soil, the water is unable to hold the water, so that is how it is like always dry. And this is the salinization, that is salt accumulation in the soil. And acidification is the soil pH, and mainly caused due to the eutrophication, or maybe because of the acid rains and and other agricultural practices, which affects the soil pH. So without the neutral pH of the soil, the plant survival will be very less. All right. So what are the detailed implications of this? So the contaminants, particularly from caused or emitted by different industries and agricultures and all these, can accumulate in the soil, posing risk to human health and ecosystems. And it also changes the pH of the soil, mainly affecting the availability of the nutrients and also the microbial activity as well. And also the salination reduces the soil fertility and the crop yield as well. So if we look into this picture, there are several problems due to the soil contamination, that is uh, leaching effect also will be one of the major effect causing it. And so mainly the soil consists of 5% organic matter, 25% of air that is getting trapped between these pores and all, and 25% of water, and other 45% is only minerals. Coming to the slope stability. So the slope is such that due to the slope only the water is conveyed. All right, this is a natural gravity slope where due to this slope only the groundwater will be getting infiltrated and recharged and all of this. So if we look into the slope stability, it is mainly the resistance of the slope to failure. That is the rock slopes, the landslides, debris flows, all these due to these only. And what are the main impacts? So main impacts is the instability of the slope and landslides during the more slopage of it, as and when during the compaction or the excavation of soil and mixing of horizons, there will be more amount of runoff, and all these there will be nil water holding capacity, so they will be slowly the slope is going to form. And this slope again has several impacts, that is the infiltration problem, and it might even also trigger the rock falls. So rock falls, rocks present on the top of the top area or the hill area, so due to this slope and all, there is a possibility of rock falls, and debris flow as well. So during this slope, there will be several landslides and debris formation, debris flow, and all, and increased erosion and weathering as well. So another impact is the weathering and increased erosion, where removal of vegetation accelerates the mechanical and chemical weathering of rock, and rainfall, freeze thaw cycles, and human activity weaken the rock structures. So, all right. So, how does human activity cause the weaken of rock structures? Because of the more amount of excavation, because of more amount of sand dwelling, soil dwelling, more amount of water pumping, and all these, ultimately leading to the triggering the rock falls and ultimately leading to the erosion, ultimately leading to the weathering process, all that. All right. And the next one is the groundwater changes and drainage issues. So mainly for groundwater and drainage issues, excavation can alter the subsurface layer water flow, and leading to an increased pore pressure, and poor drainage causes rock weathering, swelling, and loss of hair strength. The rocks are the major ones which has, like, rock to rock in between there are some pores, which is mainly called as porosity. These pores are the air gaps, and once there is an infiltration or the by rain or something, the water particles get locked or trapped into the pores, making it useful for the aquifers to withdraw the water and all. So by excavation of these, by excavation of soil and all, it alters the subsurface water flow, and which ultimately leads to the increasing in pore pressures, and also the poor drainage. Once there is a leakage of these, because of the pressure or because of the condition of the soil, there will be a poor drainage, which causing the rock weathering, swelling, and loss of shear strength. All right. And then next one is the infrastructure damage and the safety risk. So infrastructure is that the slopes particularly pose several risks to the roads. So Himalayan roads, or if we going to go to Himachal Pradesh or such places, the roads how it will be, so it will be very steep somewhere, and it will be very narrow as well. And mainly because of the slopes and all, there will be a difficult or major threat to the roads, tunnel, bridges, and nearby settlements.
And rockfalls endanger highways, particularly in the Himalayan roads, and also the mining operations as well. So infrastructure damage and the safety risk also takes place. And seismicity. So seismicity is that um, um,
Yeah. So seismicity and earthquakes particularly. So the tectonic plates and all. So there will be induced seismicity, smaller earthquakes caused by the human activities. That is mainly by the excavation process and all these, human interference is only all these seismic effects, the clashing of the tectonic plates and earthquakes or all these are caused. And the other one is the larger reservoirs, deep well injection of fluids, and some other mining operations can affect this process, and which also induce the earthquakes. And detailed implications will be, although often small, induced earthquakes can cause damage to the infrastructure, and induced seismicity may also consider for in the large scale projects as well. And so these also should be considered when a project to be implemented. And coming to the floodplains, and floodplains where urbanization, channelizations, levees, removal of vegetations are also mainly incorporated or looked into particularly. And for the urbanization, how these urbanization causes affects the soil and groundwater effort. Mainly it reduces the natural flow storage capacity. All right, so it reduces the natural flood storage capacity and increases the runoff, mainly due to the compaction of the soil because of the major concrete roads and all. They will be storage less water storage capacity and more amount of runoff. And channelization where it also alters the river flow, and which mainly causes the flood risk downstream. So the downstream, as in the people living in the low-lying areas, they will be more prone to this floods and levees. uh, levees. So these are actually can protect some areas but increased flood risk elsewhere. All right, and removal of vegetation. So with the more amount of deforestation or removal of the vegetation, water infiltration will be reduced, through which water retention is lowered, and there is more amount of increase in runoff, and runoff ultimately causing to eutrophication. And there are detailed implications such as the increased flood frequency because of all these process, and loss of natural flood control functions, and contamination of flood waters with pollutants from urban and agricultural areas. All right, now look, if you look into the subsidence, so the floodplains, and subsidence, compaction, all these also we will be seeing as one of the impacts for the proposed projects. So these subsidence particularly, so how does the subsidence also affects the groundwater and soil environments? Let's look into this. So basically, subsidence is the gradual sinking of the land surface. So if we look into this, there is a hole in the land. The reason is unknown sometimes, mainly causes in Japan, or in countries like such places where suddenly there will be excavation of it naturally formed. People say it is maybe because of the asteroids, but not just because of the asteroid, but also because of the geological formations as well, and sometimes because of the human activities as well. There will be a natural sinking of the land surface. So if you look into this picture, there is a huge water excavation here, and dredging the house. And here we see the crack, the separation of lands. So this is also because of the human activities, we can say, because of the forest and main drilling effects, and dredging and all these. And sudden lowering or sudden sinking of land surface, that this is also like a house where suddenly going into the soil suddenly, as in not all of a sudden, but yes, gradually it will be slowly, as and when there is more impacts on the soil and the groundwater, as and when is like, projects more drilling and the effect on the ground and all, effect on the layer of the earth and all, there will be this subsidence process. And mainly the impact is on the groundwater extraction. So excessive pumping of groundwater can lead to the aquifer compaction and lead ultimately to subsidence. Yeah, because mainly of the groundwater, because high storage buildings per se, or huge huge industries or huge buildings as such, they need more amount of water, due to which more drilling and more excess pumping of groundwater will be taken place, which lead to the aquifer compaction, that is lowering of the aquifer pores and reducing of aquifer pores, and also the land subsidence. So majorly that is how the land is getting compacted here. And because of the mining projects as well, mainly this mining operations, they remove the subsurface materials, and which are ultimately causing the ground above to collapse. All right, so majorly they dig and dig and dig, right? So that is how it is done, and the subsidence occurs because of this activity. And oil and gas extraction as well, and similar to the water extraction, this can also cause compaction. So the more depth you go into the earth, the more of oil and gas will be can be extracted, due to which again the subsidence can be occurred. And the detailed implications could be this subsidence can damage the buildings, roads, pipelines, and it also lead to the flooding and saltwater intrusion. So all these are the other impacts which is mainly caused. So since it is a smaller house, it is like slow, like a small amount of it went inside. But if you consider the big buildings, like for example 40-story building, 30-story building, okay, maybe even a large number of large storage buildings also. So because of this, major amount of extraction is done, due to which again, like slowly they will be like subsidence, and it also ultimately causes the buildings as well. So if we coming to the next one, that is the compaction. So compaction is the reduction in the soil pore space, which is again affecting the aquifers ultimately, and decreasing the density of the pore size. All right, so compacted maybe because of the heavy equipments or heavy transport machinery and all these. So the major impact will be due to heavy machinery, that is the construction and agricultural equipment, compact soil, and livestock trampling. Intensive grazing can compact the soil as well. Yes, more amount of grazing by the livestock animals, cow, sheep, and all. They will be like extensive grazing, due to which the soil is also getting compacted. And urban development, like high storage buildings per se, and heavy traffic also compacts the soil, ultimately leading to the compaction of the soil. And the detailed implications are: the compact soil will reduce the infiltration. Of course, it will be like low amount of water will be getting infiltrated into the soil and ultimately reaching the groundwater surface. And there will be more amount of increasing runoff and erosions. So maybe because of the constructed or these concrete roads and everything, there will be more runoff, but very less infiltration process occurs. So that is the detailed implications, and it also reduces the root growth and also the nutrient availability to the plant and soils. So if we look into the land use and mineral resources, all right. So mineral resources and land, mainly the impact which causes are the mining projects. So these mining projects disrupts the soil profiles, creates the acid mine drainage, and mainly releases the heavy metals. All right, so it disturbs the soil profile, that there are different soil horizons, right? Topsoil, humus, and all these, they are getting disrupted, and due to which acid mine drainage occurs, that is more amount of nutrients will be present with high amount of pH in the water which is getting infiltrated. And again, these also releases the heavy metals such as lead, mercury, all these also, like they release into the environment, and ultimately leading to the soil and groundwater exploitation and quarrying. And these alters the landforms, particularly changes the drainage patterns and all. And again, oil and refinery, particularly, oil and gas extraction, which can lead to the soil and groundwater contamination from spills and leaks. All right. So, what will be the detailed implications? So, there will be a severe soil and groundwater contamination, biodiversity loss, long-term environmental degradation, and acid mine drainage, which can also contribute to waterways for a very long period of times. All right. So these buffer zones. So what are these buffer zones, and how the it is getting the impact on the soil and groundwater? So mainly it reduces the ability to filter pollutants, regulate the water. Buffer zone as in where once a project is getting constructed, all right, so surrounding area of the project, uh, the surrounding area, so particularly like 2 to 3 kilometers away from the project, so these are all considered as a buffer zone of it, all right, surrounding the project. So how this buffer zone is also getting affected? It reduces the ability to filter pollutants, regulate the water flow and provide habitat, and degradation of mainly reduces the effectiveness of buffer zone functions, and encroachment, so major amount of vulnerability to flooding, erosion, and pollution. Encroachment is then occupancy means basically like encroachment of soil, encroachment of water bodies, encroachment of lakes, and all this, they they occupy the water bodies and construct something else on it, so that is how the encroachment is. And it mainly causes flooding, erosion, and causes the pollution as well. So mainly the detailed implications are the increased pollutant loading in the surface and the groundwater, yeah, and reduced habitat for aquatic ecosystems, yeah, and decreased flood protection, and also the loss of biodiversity. These are the detailed implications for it. And mainly, if we look into the impacts on soil or groundwater because of all these effects, so the impact assessment is very much necessary, which focuses mainly on the impacts to the soil and the groundwater, which are the crucial process for evaluating the potential environmental consequences of a proposed projects. It also involves several methodologies in order to evaluate the effect of the project on these two aspects. So these methodologies help in identifying, predicting, mitigation of the adverse effects related to the contamination, depletion, erosion, and degradation, etc. And the key EIA methodologies for the soil and groundwater impacts are the checklist and matrices. Yeah, mainly because checklist, because it is very simple and descriptive list of potential impacts on the soil and groundwater, and to ensures all the key factors: soil erosion, soil pollution, water table fluctuations of all these, soil compaction, soil profile. All these are all the key factors which will be considered under this checklist. Whereas, for example, like DOE, that is the Department of Energy, has given some particular guidelines for the land and water impact assessment. So these are the key factors of the checklist where we have to follow the guidelines for which to minimize the impacts on the soil and groundwater. Other one is the matrices. Matrices is the interaction matrices comparing the project activity, that is excavation, erosion, construction, industrial discharge, with that of environmental components, that is soil stability, soil porosity, groundwater contamination, subsidence, compaction. So all these also comes under the impacts. And the mainly under matrices method, Leopold matrix is majorly used, and for the qualitative impact assessment tool. All right, so this is about the impacts on soil and groundwater, and mainly a comprehensive overview of if it is a project. All right, if we completely like, so these are all like till now we have understood like what are the impacts of the soil and all, and we have seen like what kind of methodologies will be used for this, such kind of soil and groundwater impacts. And now we will be seeing a comprehensive overview of such EIA entails. Okay, so mainly about the project. So the project, we will be knowing about the description of the project. So every each and every detail will be clearly stated in the project. All right, so the detailed information will be present, be it the location, the time duration, the design, the construction, operation, decommissioning phases, and identification of all the activities that could potentially impact the soil and groundwater. All right, so every project, every detail will be present in the description of the project. And performing the baseline assessment. So baseline studies will be conducted in the study area of which the characterization of the existing soil and the groundwater conditions will be assessed and analyzed in the main study area where exactly the construction is going to happen of a particular project. And the soil surveys also will be performed. The surveys as in like the soil texture, soil type, soil pH, nutrient levels, contamination levels, the organic matter content. So all these also the analysis, the soil analysis of these will be conducted. And further the hydrogeological investigations also will be done, that is about the groundwater, the aquifer characteristics, the porosity of the soil, and the groundwater flow patterns, then flow regime, recharge areas, and baseline water quality will be assessed. And then the mapping of the sensitive receptors. So sensitive the parameters are the drinking water sources which should not be deteriorated. Wetlands are the places where it will be like natural treatment process undergoes, and the natural storage of water as well, and other ecosystems also comes under the sensitive receptors. And we have to also identify the potential impacts of all these. So what could be the potential impacts? We have already seen the potential impacts of the soil contamination from spills or leaks, groundwater contamination from leachate or runoff. So what is a leachate? So there is a leachate as in there is a for example, there is a dump yard where the solid waste is being done, dumped solid waste which includes the the domestic waste, livestock waste, whatever it is. So in the dump yard the whole kind of solid waste has will be disposed. And over the period of time, because of its organisms, microenvironment and macroenvironment, the temperature, the pH of the soil, sludge and everything, it causes the water discharge from the solid waste. So this water discharge is nothing but the leachate or the runoff. So this leachate is like a very high amount of nutrients are present in this leachate. So through this leachate and runoff particularly from the agricultural area, runoff particularly from the agricultural activities, or runoff from the mining activities, and refining activities. So these runoff once reaches the water bodies, it becomes eutrophic. Once it reaches the soil surface, it will get infiltrated into the groundwater, and ultimately causing the groundwater contamination. Soil erosion from the construction activities. So soil erosion mainly because of the deforestation, cutting down the trees and all, ultimately, and soil excavation process. So major amount of soil is removed, and the soil profile is getting disturbed and all, by which the soil erosion occurs, and mainly due to the construction activities. And groundwater depletion from excessive pumping as well. So more amount of water is getting pumped for the larger activities, the depletion also occurs. So more and more excavation of water, more and more amount of depletion occurs. Further changes to the groundwater flow. The flow regime is also disturbed because of the change in groundwater flow pattern, because of the soil erosion, because of the slope, because of the compaction of the soil. All these also ultimately causes the changes to the groundwater flow. um, so, what could be the mitigation measures for it? So, we have seen the impacts. We have seen what are the causes of these impacts and all. Now, we will be looking into the mitigation measures. So, the development of mitigation strategies. All right. So, if it is more amount of groundwater excavation, there should be a limit of groundwater excavation. Like there should be a limit, or there should be like limiting the giving licenses for a particular project or approval of the project. And also to identify the proposing measures to minimize or prevent these adverse impact. So this will be like the mitigation measures for such kind of impact. And for example, it will be like contaminant system for potential pollutants, erosion and sediment control pollution, groundwatering monitoring programs, soil water manage storm water management, proper waste management, and buffer zones. So these are all the examples of the mitigation measures what we can be taking care to minimize the impact of the project effect on the environment. So now, since we have understood the existing soil and groundwater characteristics, which are mainly crucial for the various applications, including construction, agriculture, and other environmental management activities, mainly we have to look into the soil characteristics, that is the soil composition. The soil composition, as in the proportion of the sand, that is mainly the sand, silt, and clay. Soil is all about that, right? The composition of it, and which also shows the soil texture of it, whether it is coarse, whether it is soft, or whether it is fine, and all right. So the organic matter content is also vital and influencing the fertility of the soil and also the water holding capacity. So the soil texture, the composition of it, the organic matter of the soil, all these are also the vital components for influencing the fertility of the soil and also the water holding capacity of the soil. And the physical properties are mainly the permeability of the soil, that is the availability of water to flow through the soil. And the porosity is the amount of void space. So void space is nothing but the air space in the soil, between the soil pores, all right. So one soil particle to the another soil particle, there will be air gaps, what I told you, those are called as porosity. And that air gap is actually called as void space. All right. Then the other physical property is the density of it. The mass of soil per unit volume is the density of it. And the structure, so particles of soil, how it is arranged and all right. So the finer particles on the top, coarser materials on the top bottom. So these are the main arrangement of the soil. And into aggregates, like they mix with each other and then form accordingly. And the chemical properties of soil, mainly we have to look into the pH, whether the soil is in acidity level or the alkalinity of the soil. Acidity is below the pH 7, causing the acidic soils, which inhibits the plant growth and soil infiltration. Whereas alkalinity, that is above 7, that is 8, 9, 10 pH, like that. And that is the alkalinity of soils, where more amount of soil salts can be stored. Higher the alkalinity, lower the production of vegetation. And the neutral pH, particularly from 6.5 to 8, that is a neutral pH, where it is a correct or a good pH for the plant growth. And other chemical property is the nutrient content. Nutrient content is the levels of essential elements of nitrogen, phosphorus, and potassium. And that is the nutrient content. And the presence of contaminants, the presence of contamination such as the heavy metals, pesticides, or other pollutants. And the groundwater characteristics, particularly, so these groundwater characteristics are what we have to look into is the level of groundwater, that is the water table depth, So the depth of water table should be considered, and the groundwater quality as well. So quality, again we have to check the chemical parameters, that is the chemical composition of it, whether it is consist of more amount of dissolved minerals, salts and other substances will be majorly looked into it. And the pH, whether the groundwater is more acidic or alkaline, that will be monitored. And presence of contaminations, that is whether the groundwater is getting polluted, or the contaminants from the industrial, agricultural or the domestic sources, that and all need to be analyzed. And the turbidity of the groundwater, whether it is like clear or cloudy or gray water, whatever it is. And groundwater flow, and the flow regime is also will be monitored, that is the direction of the flow and the rate of the flow of groundwater movement will be analyzed. And the aquifer characteristics, so these aquifers are the water storage between the pores in the void spaces. And that is the aquifer characteristics, mainly the permeability and the porosity of the geological formation that holds the groundwater. So these and all characteristics and parameters need to be analyzed for groundwater to evaluate the impact of it. All right. And the importance of these characteristics, so the major importance mainly particularly, um, because of the construction, that is the foundation stability. And this foundation stability, like groundwater levels and soil bearing capacity, are the critical for the building foundations, right? So by excavation and dewatering, all right, so by ruining all this excavation and all, understanding, we have to understand what are the main conditions of this ground and groundwater soil and all these, which majorly helps to plan the excavation and manage the water flow. So once we come to know the flow regime, like how the groundwater is flowing, once we know the soil porosity and the aquifer characteristics and the condition of the soil, condition of the texture, condition of the groundwater, and all this, by knowing all these conditions, then slowly the excavation and dewatering should be performed in order to not damage the condition or the existing condition of the groundwater. And the agriculture, now how the agriculture can be you like can be done in an appropriate way is that crop suitability. So based upon the soil texture, based on the pH of the soil and the nutrient content, the soil, the particular crop need to be cropped such that the soil will enhance the uh, crop productivity. And irrigation as well, so mainly the groundwater availability and the quality are essential for the irrigation purposes. And environmental management, so environmental management, the by pollution assessment and remediation practices, ground water and soil testing will also help and identify and address the contamination problems. And also the proper management of water resources, that is mainly by understanding the flow of groundwater, the flow regime of groundwater and how the groundwater infiltration and the recharge is occurring. These are the major crucial major for the sustainable water use. All right, so what will be the impact prediction? So impact prediction is that when predicting the impact of a project activity on the soil or groundwater, it is always helpful to consider across the different levels in detail, that is qualitative, quantitative and specific quantity. All right. And yeah. So the qualitative impact prediction is the level focuses mainly on describing the potential changes without assigning precise numerical values, mainly relying on the expert judgment, experience, and general understanding of the project and the environment. And it also aims to particularly identify the risks and pathways of the impact. All right. So, for example, the construction of an industrial facility, mainly which mainly causes the risk of the soil contamination due to potential spills of hazardous materials. The use of fertilizer in the agriculture may lead to the nutrient leaching into the groundwater. So the usefulness of knowing all this is to provide a assessment or preliminary assessment of a potential impacts and major key areas of the concern. and useful in the early stages of EIA. So these are all the impacts are useful for the early stages of EIA reporting. And simple quantitative impact prediction, that is mainly involves the basic calculation or estimations to provide a rough idea of the impact magnitude. All right, and it also used involves the models or the methodology of the available data, and that is how the predicted of impact prediction of the impact can be done. And it also provides a more concrete sense of the scale of potential charges. And for this example might be the estimating the volume of soil that will be disturbed during the excavation, that is the soil horizons will be disturbed, right, that one. And calculating the potential increase of runoff due to this creation of impervious surfaces. And the uses are to provide a more tangible um, assessment of these impacts, helps to prioritize the mitigation measures, and also it is very useful for the preliminary design and planning of a project. If we come to the specific quantitative impact prediction, and in this level, particularly specific quantitative impact prediction, we involve the usage of detailed models, simulations, and site specific data in order to provide precise numerical predictions of the impacts. It also requires the extensive data collection, analysis, and expertise suggestions, and it also aims to provide high degree of accuracy and confidence in the prediction. Main examples are the using the groundwater flow models to predict the extent and rate of contaminant migration, and detailed soil testing in order to determine the concentration of the specific contamination, and using the hydrological models to simulate changes in groundwater levels and flow patterns. And the users will be providing a high accurate assessment of potential impacts, and supports the informed decision making and development of effective mitigation strategies. And it is also essential for the complex projects with significant environmental risk. So that's all for today, and tomorrow we will be discussing more about the qualitative approach, how the soil will be, useful for several these things, and how it will be measured, and all we will be seeing in the next few classes. And that's all for today, and we'll see you in the next class. Thank you.